In this video, we're going to talk about great circle sailing. We'll start by comparing rhumb lines versus great circles, and then we'll do a calculation of great circle distance. So the goals for this presentation, as I said, we'll also do a quick review of last class, which was a review of rhumb line sailings, and then we're going to look at articles 902 and 903, which compare rhumb lines and great circles. Then we'll look at article 913. This is all in Bowditch 2024, volume 2. And in the description of the video, there's a link to where you can download a free digital copy of this book that's available in the Coast Guard exam room when you take your deck exam. But after we look at 902 and 903, then some slides associated with that, then we'll jump down to 913 and we'll look at the formula for great circle distance, and then this video will end, and then I'll have another couple of videos that actually do great circle distance calculations. So this slide here is just a comparison. We wrapped up last class. We wrapped up the rhumb line sailings, and now we're starting great circle sailing. But this compares the four rhumb line sailings: plain, parallel, mid-lat, and Mercator. And you're going to want to spend a little bit of time with this slide because it does a decent job of comparing and contrasting and showing the pros and cons of these four different types of rhumb line sailings. And you should expect that on an exam, exam 2, test 2 in the class, you should be able to distinguish some of the pros and cons of these various sailings in a short answer format. Okay, so in Bowditch 2, 2024, Volume 2, there is this section 902 and 903 and 904. Okay, they're chapter 9 in the sailings. And these couple of pages here have a lot of really important information, particularly that you'll be interested in the Nav General section of your Coast Guard exam. And so what you really want to read these couple of pages and try and digest this information, this paragraph, and all this stuff here, okay? But I have a series of slides now that illustrate quite a few of these points. So we're just going to go through the PowerPoint, but you should go back and read this, okay? So first of all, great circle, shortest distance between any 2 points on the globe, okay, on a sphere. So any 2 points on a globe are connected by exactly one great circle, and only one. Any great circle bisects the Earth, and there are an infinite number of great circles on our globe. All right, so what we got right here is we just got one great circle, and it's as if a plane cut through the Earth, bisecting it, and this one happens to be running north-south. Okay, so now great circles. All great circles lie exactly half above the equator and half below the equator. So this green line is supposed to sort of represent the equator going around the Earth. And you can see that any one of these great circles that are meridians here, well, here's half of it above and here's half of it below. Okay, so if we look at this red line, this portion here is above the equator and this portion here is below the equator. So it lies half above and half below. And also this one that is at an angle other than the axis of the Earth, this one also, it's half above and it's half below. Now you might have to look at that picture a little bit to see that, but that's what's going on there. Now there's an exception to this, and that is of course the equator itself. It is neither. It separates the two hemispheres. All meridians are great circles, but not all great circles are meridians. And by the way, this is only true on a sphere. The Earth is actually not a sphere, so this is a little bit of a lie, but for our intents and purposes, we'll consider the Earth a perfect sphere for our navigation here, except for most of the rhumb line sailings and such. Okay, so now rhumb line on a Mercator chart. So this could be a Mercator chart. Looks like there is some expansion going on here of the latitude scale. So yes, but you can see the parallels are all they're all parallel to each other. They do not converge. We know, of course, on the Earth they do. So this is a rhumb line. So we go from point A to point B, and the beauty of Rhumb line is that it intersects every meridian at the same angle. So I can go from A to B and I just steer 055 and I'll eventually get there, assuming that there's no leeway or current, and of course that my helmsperson can steer a steady course. So basically that Rhumb line intersects all meridians at a constant angle. But it's not the shortest distance on the Earth, okay? Usually. All right, so this is a representation of a mnemonic chart. Okay, now this one looks a little bit different. Okay, in the previous we had the parallels were all the parallels and the meridians were perpendicular to each other, and there was no convergence anywhere. But if we look at this chart, we can see that the meridians are. If this chart could extend further up, we'd see that the meridians are actually going to a place of where they would intersect. But now you look at these latitude lines and they're curved, except for the equator, but we can't see that in this particular diagram. But they're not even, and they're also curving at different rates, okay? So this one's curving a little bit faster than this one. And now this would be point A and this would be point B, two different spots on the surface of the Earth, on the surface of a sphere. And this is a representation of the Earth in two dimensions. This is a mnemonic chart, okay? This sort of style here with these meridians and these parallels, this is a mnemonic chart. And on a mnemonic chart, a straight line is a great circle, whereas on a Mercator chart, a straight line is a Rhumb line, okay? And we'll dive into that a little bit more in the next couple of animations. But the thing here is that on a great circle route, it is the shortest distance on the planet. However, your course is constantly changing. So this is this meridian, that's the direction north. So here, that's about 057. And we come over here, and this is north now. And so that angle is about 072. And we get over here, and that angle is almost 90. It's 087. And we get over here, and actually now we're in the southeast quadrant, okay? So here we were kind of going northeast. Now we're going southeast. Strange but true. So this slide is showing a great circle and a Rhumb line. But here's a really interesting thing. If I follow a Rhumb line and I just keep going on the planet, eventually I'm going to end up at the pole, and that's called a Loxodrome. And so I just want to point something out to you. On a globe, if I connect 2 points with a line, a great circle, that's the shortest distance. But this is a Rhumb line, and you can see it's actually a longer distance than the great circle on a globe. Okay, so now let's check this out. This again is a mnemonic chart. So the green line is a great circle, and the Rhumb line is a curved line on the mnemonic chart. And it's curved towards the equator. So the equator would be down here somewhere. North Pole would be up here somewhere. So on a mnemonic chart, a great circle is a straight line, and a Rhumb line is a curved line, and it's curved, it's bowed towards the equator. Okay, but check this out. When I go from a mnemonic chart to a Mercator chart, what I really do here is I take my meridians and I make them parallel to each other. So I stretch them apart, and the closer I get towards the pole, I stretch them more. Okay, and then I also have to stretch my latitude. But when I make all these lines parallel to each other, it's going to change the shape of these lines. The green line will become curved, and the red line will straighten out, just like this. So this is now a Mercator chart. The great circle appears to be a longer distance, but in fact, it's a shorter distance. This is distortion, okay, created by taking a spherical Earth and representing it in a two-dimensional chart. The Rhumb line is now straight, but it's a greater distance. So here, intersecting all the meridians at the same angle, here intersecting the meridians at varying angles, okay? And I'll just show you that animation one more time. Okay, when the meridians are converging, the great circle is straight, and the Rhumb line is curved, but on a Mercator chart, it's just the opposite. This is the shorter distance. So this is a Mercator chart, I can tell, because the meridians are parallel to each other. And so this is point A, this is point B, and this is the Rhumb line. And it's 3,227 miles. And the convenience there is that you just steer the same course the whole time. This is the Great Circle track. This one is shorter. Okay. Now, the fascinating thing here is that it looks longer, but in fact, it's shorter because you got to remember that those meridians are actually converging. Okay. So a great circle is a curved line and it's curved towards the pole. This is a little bit different than the Rhumb line. Okay. So on the Rhumb line, when we're on a mnemonic chart, the Rhumb line was curved towards the equator. Okay. And on a Mercator chart, the great circle is always poleward. It's always curved towards the pole. And so if you follow a great circle chart, you'll always go closer to the pole than you will on an equivalent Rhumb line. Okay. Now, vertex. So the vertex is the point along the great circle track where you reach your highest latitude. So that would be right around here. Okay. And if you were to follow this great circle track and went all the way around the world, there would be a vertex in the southern hemisphere. And whatever the number is of this latitude, let's say it was 50 north, the vertex on the other side would be 50 south. Okay, so what kind of chart is this? Mercator projection. All right. And what kind of chart is this? Mnemonic projection. All right. And here's our vertex on the mnemonic projection. Okay. Now, when we're actually doing a voyage, we usually don't actually do great circle, a complete great circle route. What we'll do is we'll do an approximation of a great circle. And it's quite a bit of extra work to do a great circle than it is to do a Rhumb line. And so you really want to make sure that it's worth doing that extra work. I'll explain that more in a future slide, but here I just want to show you the general idea. To do a long voyage here, we start off on a mnemonic chart, and I go from here to there. And then what I can do is I can just sort of snap off 5-degree differences in longitude and just make these waypoints. And I can take those waypoints, I can get the latitude and longitude of each of those, and then I can transfer that to a Mercator chart. And I get these points. So this point becomes that point, this point becomes that point, so on and so forth. And then what I do is you basically steer a Rhumb line between these 2 points, and then a Rhumb line between these 2 points, and a Rhumb line between these 2 points, and a Rhumb line between these 2 points. And over the course of the voyage, you approximate the great circle. This is the actual Rhumb line if you went from San Francisco to Yokohama, okay? But that would be a longer distance. This great circle, although it appears to be a longer distance, is actually shorter, and we can approximate that voyage. So we would steer the same course here, and then we would change course a little bit, and then we would change course here. We steer the same course, then we change course, and that we'll talk more about that next class about how to do this. Okay, so there's our vertex. It's the highest latitude, and there's the same vertex right there. Okay. So let's talk about vertices for a minute. So I got 4 different voyages here, okay? And we're going to just look at these one by one. First voyage we're going to look at is this green one, okay? So if we were to follow this voyage here, we would start here along the midpoint of the eastern seaboard of the United States, heading over towards the Strait of Gibraltar. So if you look at this is a latitude line here. This is another latitude line. This is 5 degrees of latitude. But anyway, so as I go along my voyage, I'm getting farther and farther north until I reach this spot where I'm the most farthest north. That's the vertex. And then my latitude starts to decrease. So on this particular voyage, my vertex was ahead of me. I went through my vertex. And then as I continued on the voyage, my vertex was behind me. Okay, my closest vertex. Remember, there's another vertex in the southern hemisphere. Okay, so that's this leg, the green leg. Okay, great. So we passed through our vertex. It was ahead of us, we went through it, and then it was behind us. Okay, so let's look at this leg. So we start down here, maybe in Puerto Rico, and we head over to the Strait of Gibraltar. So on this voyage, I'm getting farther north, farther north, farther north, farther north, farther north, and then I stop. If I was to continue on this voyage, I probably would actually start getting further south. Okay, so in this voyage, I ended at my vertex. Okay, so this one I went through my vertex, and this one my vertex was ahead of me the whole time, and then I stopped at my vertex. So that's the red line. So let's look at I think it's the blue line next. Okay, yeah, the blue line. So we're coming here off the South America. This is probably around Brazil here, okay, and we're headed up towards Europe, all right. And in this voyage, my vertex is actually up here somewhere, okay, and I actually never get to it. It's always ahead of me, okay. So that's interesting, all right. So somewhere up there, all right. So this, I went through my vertex here. I ended at my vertex here. If I did this part of the voyage, I never actually got to my vertex. It was always ahead of me. Now this one here, going from the eastern seaboard down to the South America here, my vertex. I start here and I go down there. Well, my vertex is way up here. So here, my vertex was always behind me, the closest vertex. So I'm making this point because this is going to be these are things you need to be considering, but also there's going to be some questions on the Nav General section about these kinds of concepts. Okay. So anyway, every great circle has two vertices, one in the northern hemisphere and one in the southern hemisphere, and we'll talk more about those. But they have the equal number. Okay, so if my vertex is 50 north in the northern hemisphere, it's going to be 50 south in the southern hemisphere. Okay, so you might pass through your vertex or you might not on your voyage. Okay, great. Now, why do we care about the vertex? Well, we care about the vertex because remember, if we're following a great circle, we're going to be going more poleward than the Rhumb line. I don't know if you remember that picture, but a great circle is always shorter, and it always travels closer to a pole than the Rhumb line will. And as you get closer to the poles, things can happen that might not be so good, like you might encounter ice or bad weather, okay, land masses. So we sometimes use the vertex to basically limit our latitude, basically because there might be some navigation restriction due to some kind of hazard like ice, bad weather, land, okay? And we're going to discuss more of this in a couple of classes when we do voyage planning and composite sailing, okay? So hold on to that, just planted a seed there. Now, Rhumb line versus great circle. Under what circumstances does a great circle represent significant savings of distance over a Rhumb line? Remember, a Rhumb line is pretty easy. You just start from A, go to B, snap a straight line. But the great circle, you got to do that on a mnemonic chart. You got to pluck off those positions and then transfer them to a Mercator. It's a lot of extra work. So you don't want to do it unless there's going to be significant savings of miles. You're going to have a significantly shorter voyage. Okay, so when does a voyage of a great circle voyage become significantly shorter than a Rhumb line? And there's these three conditions, and this is from Article 903 in Bowditch. So these are three conditions, and you have to consider all three of them simultaneously. So as the latitude increases, so if you're down near the equator, you're going to have less advantage of a great circle. You'll have less savings in a great circle than you will if you were closer to the pole. So the closer you get to the poles, the farther you are from the equator, the more possibility you have that a great circle will save you significant distance. So that's one condition. Now, here's another one. As the difference of latitude between 2 points decreases. What's that? So difference of latitude. Oh, that's little L. So this is basically saying as you do less north-south, you do more east-west. So if you're doing more east-west, you're going to have the possibility of having more savings. So now we can put these two together. If I'm going east-west down near the equator, probably not so much savings. But if I'm going east-west closer to the poles, probably some savings. And then this third one works with these as well. So, wait a second, sorry about that. So, what happened there? Oh, okay, all right. Okay, this one, okay. So this one here is as the longitude increases. So the longer the route is, the more potential you have for great circle to be giving you significant savings. So if I'm down near the equator and I'm going east-west on a long voyage, well, I may not get very much savings. But if I'm closer to the pole, going mostly east-west, and my voyage is getting long, then I'm probably going to have some savings. And it's going to be worth me doing a great circle. All right. So, so there are some strange situations where a Rhumb line and a great circle are actually the same thing, and that is the equator, okay? Because you're always going 090 or 270. It's a great circle, but your course is constant. And any meridian, you're either going 000 or 180. So those are the two exceptions where a rhumb line and a great circle are the same thing. Okay, and you'll notice here though that I'm going north-south, and there's no east-west, so there's no savings. Okay, all right. This is just an interesting slide here. This slide represents the longest great circle track that you could do by a boat on the planet. Let's say you started up here in this area of Russia and you went down into the Pacific. You continued down through down south to South America, up between Africa and Madagascar, and you end right over in here, Pakistan, on the border of Pakistan and India here. Okay. So anyway, that's just an interesting, that'd be the longest great circle you could do. Now, of course, if you were flying, you could fly the entire thing. You'd probably need in-air refueling though. Okay, now that ends section 902 and 903. Now what I'm going to do is I'm just going to talk to you for a few minutes about, I'm going to introduce to you Great Circle, these two pages. And so we jumped to 913, okay? And this is the section of Great Circle sailing by computation. So let me just zoom in here for a second. All right, so here we are, Great Circle by computation, and you probably want to read this little section here, but then we get down here and then there's these formulas down here. So we're going to be using, in this course, we're going to be using the cosine D and the tan C formula. Now, these are some other Great Circle formulas, okay? These ones here, we're not going to use those until ANAV, all right? But if you need them for some reason, you can find them right there. But we're going to be using these two formulas, and there are some rules associated with those formulas, and they're written right there. So the cosine D has one rule, and the tan C formula has three rules. It turns out that the first rule is the same for both of them. If you're crossing the equator, you got to make L2 negative. But for the tan C formula, there are three rules, which is once you solve for C, if it's negative, you got to add 180. And then the rules for converting C to Cn are different for Great Circle than they were for Rhumb Line. I had warned you that they were. The prefix will be named by the name of L1. So if you start off in the northern hemisphere, your prefix will be north. And if you start off in the southern hemisphere, your prefix will be south. We'll talk more about this in class. Okay, and then over here, you've got your example 1 and your example 2. What I'm going to do now is we're going to go to the next slide, which sort of just focuses in on the formulas that we're going to use in example 1 and example 2. All right, so this is an excerpt from that page. So here are the two formulas that we're going to use and their rules, and then here's example 1 and example 2. Now, this first rule of crossing the equator, make L2 negative, make L2 negative crossing the equator. This first example is an example where L1 and L2 are on the same side. So in that case, we're not crossing the equator. And anytime you enter the value of L2 in these formulas, you would make it positive. But over here, we're going 28 north to 24 south, so we're crossing the equator. So every time we enter in a value for 24, for our second latitude, we have to make it negative. So you can see here that the 24 is made negative. Over here, the 20 is positive, but over here, the 24 is negative. So that's something you're going to have to pay attention to. All right. And you'll have that information. These are some notes that Captain Parrott put together. These are great notes. However, you're not going to have these on an exam. This might help you kind of put everything together in one page, but you should also learn to decode what's in Bowditch because that's what you'll have on exams. So now in class, I'm not going to spend much time on this, but in class, I'll show you how you can actually use your calculator to solve. These are actually keystrokes that I'm going to show you how to do these calculations in class when I see you. This slide here is also, I think this was put together by Captain Parrott, but this basically shows the rules and conventions for the Great Circle distance formula. All right. So I'm going to, this is basically the procedure that we're going to follow. And, I'll show you this in class and I'll show you how to do this. And I'm also going to, you have this template in your handout packet, and I'll show you how to use this as well. Okay, so that concludes this. What you should do now is go to Canvas And now you can start to do great circle problems. And I have a couple videos of a couple different types of problems for great circle distance. And then I will see you in class. Thanks.